Now let's look at a new topic, which is complement of a set. So, complement of a set. First thing is you need to remember a few points. Like one is we are building up when it comes to complement of a set. We are forming a set in relation to a universal set. If you remember what a universal set is a set of all sets with respect to the other sets which are under consideration. So let me give you an example. If I say, if I have a set which is set A, which has got a singleton set A, and I have got a set B which has got another singleton set called I, and I have a set by the name U, okay, and I have got a set of vowels which are vowels of alphabet A, E, I. I have just interchanged them, A, E, I, O and U. Okay, so you will see that A is the sets A and B are subsets of the universal set U, are subsets of U, of the set U. That makes this set U a universal set. So these are the sets under consideration which are subsets of this main set, which is U, which has got vowels of alphabet of all the English alphabets. So A is a subset of U and B is also a subset of U. That makes U a superset as well as a universal set. Okay, and these are the sets under consideration right now. Okay, so now we know what universal set is. So complement of a set is in relation to a universal set. So if we take the same example, okay, set A is capital A, set A is having a singleton element A, and set B is having a singleton element I, and we have a set which is U, which is a vowel A, E, I, O, U, which is the vowels of the English alphabets. Now let's find out the complement. So when I say complement, it is a difference basically of two sets, but the main set being the universal set. It is basically a difference. So now when I say complement of a set, what I am doing is, rather than having a specific thing as A minus B, what I am doing now is every time subtracting any set from a universal set. Now if this is my universal set, so my complement of a set becomes, in this case, we have to do the same which we did, the same operation we did for a difference of a set. So you subtract U minus the set A. So we just know the rules that first is we need to locate a common element first. Common element here is A. So in U and A, we have a common element A. So A needs to be removed, and rest are all our sets, are elements of our sets, which form the complement of this complement of a set. Okay, so the set under consideration here is A. Okay, and with respect to A, we are forming a difference. So the rule to find the differences, first you find the common element. Here the common element is A. So U minus A. So what we have is basically the rest of all the elements. And this set of all elements form the complement of the set A. Okay, so when you say complement of a set, of any set, you have to subtract that particular set from the universal set. Okay, so just remember that. And let's find out the complement of B. So we can call this what we have right now as a complement A. Complement is indicated or denoted as A and on the top an apostrophe, okay, or a tilde sign, no, not a tilde sign, sorry, an apostrophe, a dash kind of a thing. And then you have, now this forms A, E, I, O, U. So since I've written the letters in this order, I'm maintaining this. So now let's find out complement B. So whenever I say complement B or anyone says complement B, you need to subtract this element from a universal set. A universal set will be different for different problems. So universal set will be defined. The set A will be defined. The sets under considerations here is A, B and U. So all these will be defined in your problem. Okay, so if I want to find out complement B here, when the consideration of the sets, the sets under consideration are A, B and U, then complement B is what? So we have to find the difference. Differences, we first find the common element. Common element is I. We remove that element and then we get A, E, O and U. This is the complement B. Okay, I'm sure this must be clear. Okay, just remember these points. The complement of a set is always a difference of that set from the universal set. And all these sets will be clearly defined to you. The sets under consideration will be given to you. Okay, so just remember, when I say A complement, I subtract the set A from U, from the universal set. If I am asking you B complement B, then I subtract B, set B from a universal set. Just remember that. These are very important points. Okay, now let's understand some properties of complement of a set. Okay, so we'll consider our same example. Our set A is a letter A and our set B is letter I, and our universal set is basically a set of vowels in the English alphabet: A, E, I, O and U. Okay, so now the first property states that, I'll write it over here. The first property states that A complement is equal to A. So let's see this. So A complement, we've seen that A complement is basically removing the common element. We have E, I, O and U, and again finding its complement. So what I am doing is I'm subtracting A complement from the universal set. So A complement. So I have A complement here and I have the universal set here, right? So finding out the difference. So how do I find the difference? I find the common elements. So I find the common elements. Common elements are E, common elements are I, common elements are O, common elements are U. So what do I get? I remove these common elements, and what I get is element A, which is actually set A. So the first property, A complement okay, is equal to A, which holds true. Now let's look at the second one. Phi complement, this must be interesting, is equal to U. Okay, so let's see this. I'll just erase now. I need to see what phi complement is. Phi is what? It's an empty set, right? So when I say phi complement, what I am doing is I am subtracting an empty set from a universal set, right? So every set, you remember, has a empty set. So a universal set will also have an empty set. So this set, for visual appearance, I can write this set as A, E, I, O, U, and I have phi. Okay, this is an empty set. Okay, so every phi is actually a subset of every set, so which we have learned in the earlier sections, properties. So now you have phi, a set of phi. So this is actually an empty set. Phi represents an empty set. So you can see, if I subtract a universal set minus an empty set, what do I get? The same rule applies. You locate the common elements, which is phi in this case, remove them, and the set you get is A, E, I, O, U. So this is actually our universal set, right? So the second property also holds true, right? Now let's go to the third one. This is complement universal set is equal to phi. Okay, now what I want you to do is, based on the first and second, please put down in the comment section the third and fourth part of it. Okay, so that you yourself have a clear understanding of how, and using the same sets which I have given above. If A is a subset of B, then complement B is a subset of A complement. Okay, B complement is a subset of A complement. If A is a subset of B, then B complement is a subset of A complement. So do these 2, 3 and 4, put it in the comment section, and let's see how it goes. Okay, so catch you in another law of the same video, which is DeMorgans Law. Let's understand that now. Now look at a law which is DeMorgans Law. So I have the same sets which I am keeping as references. So set A is A, and we have a set B which is I, and I have another set which is, I'm calling it as U, which is a universal set, and A, E, I, O, U is a set of vowels in the English alphabet. Now considering these three as our sets under consideration, I'll be finding out if DeMorgans law is true. Okay, so I'll just show you. It states that complement of A union B is equal to complement A intersection complement B. Okay, this is our LHS and this is our RHS. Let's see if it holds true. So A union B is, so we are actually finding out, I'm directly writing A union B as a set which is A and I. Okay, A union B is, and now complement of this is basically I am subtracting from the universal set. Okay, so what do we do is basically remove the common elements, that is I'll remove A and I and keep rest of the elements. So what do I get when I remove? So I get the complement of A union B is E, O and U, right? So, and now let's do the RHS. So I'm writing this part down so that it does not come under. So the complement of A union B is E, O and U. And now let's look at the RHS, which shows A intersection, sorry, A complement intersection B complement. So let's look at A complement. A complement is subtracting from the universal set. A complement is I, so we just have A complement A, the set complement set A will not have A element in it, so we have E, I, O and U. And B complement, just look at it, so I will not be there, so we have A, E, O and U. So let's now intersect both of them. What is intersection? Intersection is basically only the elements which are common in it. So what are the elements which are common in it? So E is common, yeah, O is common and U is common. So we have elements E, O and U. So we have seen that the LHS is equal to the RHS. So rather RHS is also equal to LHS. So hence it's been proved. So you could take your own examples, see if you can prove the DeMorgans law. Okay. So now let's look at the second law of DeMorgans law. So the second law, it states that the complement of A intersection B, the complement of A intersection B is equal to union of A complement B complement. Okay, so find this out yourself, put it in the comment section, I'll reply back on the same. And if you it should be pretty easy for you right now with so much of fundamentals getting cleared. So just put it in the comment section. I'll revert back if you require another video on this. Subscribe to my channel, click below, and then ring the bell if you want a notification. And now let me see you on the next video. Bye.